this remote tower webinar from FREQUENTIS DFS AEROSENSE. I brought a couple of interesting speakers with me.
A remote tower is a very young topic. What we have done, nobody has done before. At the moment, 4 remote tower projects are already in operation, and we are executing currently 3 more projects all over the world.
So on December 4th, 2018, the permanent operations in Saarbrücken have started. It's about 15,000 movements a year, which is not a lot. This system was not designed and is not validated just for this relatively low traffic, but it was validated against that peak hour. We have no real restrictions when it comes to the quality of service and the capacity. We are doing all the procedures just as we did them in the conventional tower. Reduced runway separation, reduced separation in the vicinity when the aircraft is inside of the controller, and also the fully IFR-VFR integration in the traffic pattern is done in Saarbrücken on a peak day through the remote tower system. In the long term, it's about the staffing and the reduced maintenance costs. You don't have a full-scale tower building on your airport anymore that you need to maintain. You don't need your controllers on every single airport.
We made the decision to build a new tower and air traffic control center, as our old one was beyond end of life. And we built a new conventional tower. One of the biggest adjustments for us for moving from the old tower to the new conventional tower was the new perspective that the new tower brought. We were much higher up, much further away from the runway, and we had to adjust to different perceptions of speed and positioning of aircraft compared to what we were used to. We started looking at remote tower technology. We were very curious about the technology as we were painfully aware of the disruption and cost of building a conventional tower. Our conventional tower and ATCC cost just under £12 million to build. And it was immediately obvious to us that we could have built a remote tower for a fraction of the cost, and it would have been more technologically advanced. We also liked the idea of the operational efficiencies that you could build with multi-units. We started planning to build a remote tower contingency. We aim to be the first operational remote tower system in the British Isles. This would mean that we could provide contingency, maintaining business as usual without requiring a reduced movement rate. It was surprisingly a short time before controllers actually reported feeling quite comfortable at the remote tower. And at one point we did achieve a movement rate of 34 per hour.
For the Air Force and the Navy, remote tower technology presents an opportunity to save the funds in building new brick and mortar control towers. A new control tower costs us somewhere between $12 and $15 million by the time we spend all the money to put the equipment into the tower. And the other benefit, of course, is we could probably control several bases from one location, and that would give us even more savings in the future. Many of those towers that we have, particularly in locations like Afghanistan or Iraq, have come under small arms fire and other types of small arms weapons. And if we can use cameras instead of putting human beings physically on the airport location, clearly there's a big benefit for taking the people out of harm's way. And then kind of what's really picked up more interest, I think, is that at least for the U.S. Defense Department, part of our strategy now is that many of our bases in forward locations are probably very vulnerable. And so we would benefit from having a capability that would allow us to quickly relocate to another location that may not have a brick and mortar tower. And the remote tower technology would give us a real agile, quick setup capability. The other thing is that frequently defense operations are conducted at nighttime, and the infrared capability of the cameras clearly provides very good resolution